All right, there's a question online from Erica Jawan. I will read it out, but I just want to note that nominally we're shifting into a discussion session that goes onwards from here. So feel free to step up and ask questions of any of the speakers from here on forward, not just Humberto. So this question for Humberto from Erica. Is there any difference in the inclusion-like exogenic material compared to the other standalone boulders in morphology or spectral characteristics?
That's a good question, Erica. We do find some spectral differences between the different morphological groups. We're working some more on that, but there does seem to be a spectrum in the four colors of the camera, because we didn't get enough OVIR spectra of these objects because the footprint of OVIRs was large enough and it didn't have the coverage that the camera did. So in the four colors of the camera, we do have trends between morphology and spectra. And I didn't discuss this in part because of our short time, but again, I'll be happy to discuss it some more with you, Erica.
Oh, we've got a question in the room.
Sure, I'll ask my question. I was going to ask Mihai afterwards, but I'll just ask you right now. In your experimental work, when you look at this dust lofting, it seems like a lot of times the dust has a sort of similar trajectory. Do you see large influences of the dust size, and can that tell you anything about the charge that has to accumulate in order for this lofting to happen?
Yes, absolutely. So there is even a simple relationship that the ejection speed is inversely proportional to the radius of the particle. Yeah. So that's one statement. And then, of course, once you are off the surface, so you overcame adhesive process, then it's only the sheath electric field, and from there on it's F equals ma, simple mechanics. So the orbits, they look alike. They are nice parabolic orbits.
Yeah, but you don't see any that are going like way higher than any other ones.
I think time to time, so the error bars on the speed measurements are quite large. So there are particles, and that has to do, you know, how much charge you have to accumulate before you could break through from your neighbors. And there could be a huge variation in adhesive forces between grains and grains. So the error bars on our speed measurements, actually not error bars necessarily in the speed measurement, but the spread of the initial speeds is really high due to that.
Okay, I have a question for Erica, if we still have you.
Yep, still here.
What's the limiting factor on how small you can go with your study, at the smallest boulder size?
Yeah, so the biggest restraint is that the OVIRs and Otis footprints are larger than basically all of the boulders in Nightingale. So we've got like a 24-meter boulder in Nightingale, and the non-recon data from OVIRs are like 20 meters per footprint. So to get around that for the spectral and thermophysical analysis, that's why we're doing this clustering algorithm and figuring out within each recon footprint for OVIRs and Otis, even though they're way smaller than for the global data set, they're still, 5 meters or so. So if you figure out that there's, 20% of this boulder type and 30% of that boulder type, and you basically build up the statistics of each footprint, then you can use an unmixing model to figure out the spectral characteristics of each component boulder type. So that's why we're doing all of this clustering and characterization in a bunch of different ways first, to make sure we have the most robust classifications before we do the spectral and the thermophysical analysis. But then after we do those, we're going to do some more clustering and classification and see if all of those data are still consistent. And we might need to iterate and go through the whole analysis again if it turns out that the spectral and thermal data are totally different. But then like the 2 meter, the smallest size is really limited by the OLA data. That's the smallest size boulder that we can really get any kind of meaningful surface roughness number for, because the polycam data are so great that we could go down to a meter or even smaller, especially at Nightingale.
Okay, thanks for that.
Yeah. Kevin, I can ask you a question.
Sure, fire away.
What do you think the distribution of dust is like deeper in the subsurface, down past the like tens of centimeters layer? Do you think it's as dusty all the way down into the interior, or is the finest fraction sort of concentrated in the near surface?
Yeah, that's a great question, and this is something I wanted to point out since there was a lot of discussion of dust and dust loss on asteroids. There were two OSIRIS-REx papers out last week. One was mine, which I presented. The other was a Loretta et al. Paper in Science. And in that paper, he quantified the amount of dust in the upper few centimeters, I think, based on a before and after set of images from a navigation camera that was of the exact same scene, and the change in the image properties. They were able to extract some estimates for total mass of dust that was excavated. So there is some dust in the upper surfaces of Bennu, and it's actually quantified in that Loretta paper, which might be a useful data point for some of the studies we've heard from your group. And then I also suggested to Dan Britt that there are some hints of strength with depth, both from the SEI artificial impactor on asteroid Ryugu and from crater morphology on Bennu, and there's been a theory rattling around the OSIRIS-REx team that there is a subsurface layer of finer particles some few meters below the surface that is being revealed in some of the deeper craters. That hasn't really been confirmed yet, but it's an idea rattling around. So I'd say that there is some suggestive evidence that there has been some fine particles have sequestered in the subsurface of Bennu. Whether they would be small enough to be considered dust, or that's where our millimeter particles are or centimeter particles are, I'm not really sure. But I do think that we will find more and more smaller particles the deeper and deeper we dig in Bennu. So I don't know if I weaseled out of that or if that was what you were looking for. And there's also evidence in the particle counting at the crater afterwards. There are more smaller particles revealed in the region after sampling. So it's suggestive that below the surface there were more small particles, but that's visible, the tens of centimeters particles, not dust. So we may be talking apples and oranges. All right, are there any more questions for any of the speakers? If not, we're getting pretty close to 5. It's 5. We're after 5. So if there aren't any online or in the room, then we can all go to the event that starts at 5. So thank you to all the speakers, especially the ones who signed on virtually.